In this problem, we're building a sign chart for a polynomial given in factored form. The polynomial here has several factors. It has the form x plus 4 times x minus 3 times x minus 5 squared. And so we take that expression down here, and we're going to look at each individual factor first before thinking about what it looks like in the product. One word here is that the question here is answering a question about the polynomial being greater than 0. We're going to ignore this question for the time being. We're going to make the sign chart for this polynomial and then come back and see how the sign chart helps us actually answer this actual question. For each factor, I'm going to give myself some extra lines here to keep myself lined up. For each of the factors, so let's start with x plus 4, I'm first going to figure out where that factor is equal to 0. For what value of x that particular factor is equal to 0. So in this case, that'll be negative 4. So when x is negative 4, x plus 4 will be 0. And like I've been doing before, I'm going to kind of give myself a little bit of a dashed line here to keep myself lined up so I can see that that 0 is supposed to be under the negative 4. And then to each side of negative 4, I'm going to test some values of x in this factor where I don't really I don't want to do the actual calculation. I want to just write down whether the result is a positive number or a negative number. So for example, if I go to the right of negative 4, let's say I go to 0, which I labeled there just to make sure I had this thing centered. If x is 0, then this factor is clearly positive. 0 plus 4 is a positive number. So I know that I'm positive out here. And because these factors, we've already written down the one place where that factor was 0, I know that I have to be positive everywhere else. So if I'm positive once to the right of negative 4, I've got to be positive always to the right of negative 4. Then if I go to the left of negative 4, an x value of like negative 5 or negative 6, if I were to put negative 5 or negative 6 in for x here, my result would be negative. And so onto the left here, I'm going to put minus signs. So I'm going to repeat this process for each of the factors. For the factor x minus 3, it's very similar. That is equal to 0 when x is 3. So let me label the 3 here. Put a 0 down here. Give myself a little bit of visual cue as to what I'm lining up there. And like before, I'm going to sample on either side of this 3. And so to the left of the 3 would be my 0. 0 minus 3 is negative. So I know that I'm going to be negative over on this side, and I'll be negative forever over on this side. To the right of x equals 3 are numbers like x equals 4 or x equals 5. If you put one of those into this expression for x, you'll get a positive number. All right, so I have one more factor to go. This one's a little weird because it's got this squared on it, so I have to think a little bit harder about it. But I'm going to go through the process the same way. First, where is this equal to 0? The answer to that would be x equals 5. So when x equals, oops, didn't mean to make it green. When x equals 5, this third factor is 0. And again, I'll give myself a little visual cue as to what I'm lining up. To the left of x equals 5 are numbers like x equals 3 or x equals 0. So I can pick any of those and plug it in here, and I'll have 3 minus 5 squared or 0 minus 5 squared. And the bottom line is that when you're taking a number and squaring it, the answer is always going to be positive. So whether you have a negative number squared or a positive number squared, the result's always going to be positive. And you can certainly plug a number in to check that, but that's what you'll find to be the case. So if we go this way, we're going to have all pluses. And the same this way, we'll have all pluses. The result of squaring something is always going to be positive or 0. So again, we can do that by sampling, but we also can just apply that fact. Now I need to look at the sign, SIGN sign of my product by looking at the relationship the product has to its three factors. The first thing I'm going to do is move my zeros up because I know that 0 times anything will be 0. So in this column, 0 times a negative times a positive is 0, 0. Anyway, so having a 0 as a factor means you have 0 as a product. And now I can just sample in each region. So out here, I would be multiplying negative times positive. That'll be a positive result. When I'm in this region, I'm multiplying positive times positive. So that'll be a negative result. In this region, I'm multiplying positive times positive. And the same thing is happening out to the right. So in those regions, I multiply all positive numbers. So this is what my sign chart looks like for the polynomial. That's the product of these three factors. And now finally, I can go back and ask myself, what was the question again? The question here is to figure out where that polynomial is greater than 0. And so what that means is greater than 0 means on my sign chart, well, let me just say it directly, it means I need to have a plus on my sign chart. So I'm looking for the values of x where I see a plus sign on my sign chart, not a plus or 0, right? This is not greater than or equal to 0, but just positive. So I can highlight that on my number line. Places where I have only a plus would be here and here and here. All those places where I see the 0, I do not want to have those highlighted. So I'm trying not to highlight at -4, trying not to highlight at 3, and trying not to highlight at 5. So on the number line, those should look like open circles, the non-filled circles. So I can move that picture over to my this little drawing tool. I'll have -4 with an open circle. I'll have the shading going out this way. I'll have an open circle at 3 and an open circle at 5, and I'll have the shading in between and also out this way. So that should be the shading that I supply with the drawing tool. If instead of asking for the shaded number line, it had asked for the interval, then all I need to do is convert that shaded number line into interval notation, and the interval notation is already designed to do that easily. So let me just move this over just a tad so I have more room to write. So for example, this first shaded bit I have up here, that would be represented with interval notation by -infinity to -4. The fact that that's an open circle, an unshaded circle in the -4 is reflected by having a rounded paren in the interval notation. Since we have disjoint pieces here, I connect those with my little u, the union symbol. The next interval is going to be the numbers between 3 and 5. So I'll have, say, 3, 5. And again, I'm not including 3 and 5, so those will be connected by rounded parens. And then finally, I have everything from 5 to infinity, once again using rounded paren at the 5. So I can answer a question like this where the answer is an interval by just typing in the interval that corresponds to the shading on the number line. But notice this shading came from this shading, and so I could have gone directly from this shaded picture to my interval notation just as easily.